Okay, so I guess this is the last session for everyone, and I guess everyone has been a really long week, and I hope you learned a lot from Cisco Live. It's been 3 years we hold this in-person Cisco Live. We're really excited to meet you guys, and I really hope to see you guys next time. So this session is breakout data center networking 2991 and streaming telemetry on Cisco NXOS. So my name is Shangxin Du. I'm technical marketing engineer from the cloud networking. And in my organization, I'm mainly focused on the automation of Cisco NXOS and including all the API you can think about, and NICONF, YANG, GMI, and also streaming telemetry. I'm also working on the automation on our controller, which is the DCM and NDFC. I'm also working on that. So basically, all my focus is on automation, and I don't like to touch GUI, I don't like to touch CLI. This is my interest here. So streaming telemetry is also part of automation, right? And that's why this is also part of my job. And just for the record, for stream today, the telemetry that we are going to talk about is purely on software telemetry. We know, and I know we have hardware telemetry capability support on Cisco NXOS, but today's topic will not cover anything about hardware telemetry because so far the hardware telemetry can only be consumed by our own data operation, which is NXOS dashboard insight. So we're talking about software telemetry, and let's see what we can build with the software telemetry, just streaming the information directly from the box. So first thing first, and I will try to save some time for the question, but I might not have. And we have a WebEx space, and feel free to put your question in the WebEx space. I will make sure you get your answer. If I couldn't answer that during the session, I will make sure you get the answer before you go to the flight. And also, this is the last session, so I can stay here for a little longer. If you have any question, please come forward after the session. Good? And this is today's agenda. And so we'll start from why. Why do we need the telemetry? Why do we need streaming telemetry? I think streaming telemetry is adding something new to your switch. Probably this is not something that you already done in your network. So why we want that? Why we want to use that? And if we figure out, okay, I probably need the streaming telemetry for my network, how do I do that? Where I can get the information I want, this is what the data source talking about. And how do I subscribe this data that I want to use event-based telemetry or is it a simple-based telemetry? So how do I subscribe? And also the encoding part, is this more related, okay, the data, the wire efficiency, and how do you decode the data, the format of the data. This is what the encoding part play. And also there's some design consideration, right? Telemetry, and you probably have heard of that we have different way to subscribe the telemetry, or sorry, different way to stream the telemetry. They are out, they are in. You probably have heard of this option before, but there are some design consideration combined with that. So you really need to think about that before you choose one, okay? That's a design consideration. And the last thing is, I promise I will get you something you can take back to build in your lab and test that really quickly for your lab. And eventually, I hope you can put the streaming telemetry on your production network. This is how we build the telemetry system with open source tools. We're going to talk about some information about decoding, encoding, the format. And this is more like related if you want to build your telemetry system by yourself, like literally writing the code. We do have a customer doing that. But most of our customers, they want to use some open source. We do have open source out there, and they want to build a system just using the open source tools that you can do, okay? So first thing is why. Streaming telemetry is all about observability, right? We're talking about observability all the time. We want to correlate the information. So this is a fabric you build. Yeah, you build a fabric. It doesn't matter how you build that. You build the fabric line by line, just the line by line on each individual device, or just build it from some other automation way. Doesn't matter. It's running perfectly. But there's always some question in your mind when you have a lab running, right? You always asking, okay, is my BGP neighbor are all up, and you want some planning, and is the capacity is still holding up, and is the uplink, do I need to add more uplink between the leaf and the span? And because I have too many applications connected to this leaf, right? And also, switch doesn't always run perfectly. There's always some problem. There's always. And when you have a problem, when you have an issue, when you open a tag case, especially when the issue is related to data plan, what is the first question your tech engineer is going to ask? So I was a tech engineer. Actually, I would not go for show tech first. I was a tech engineer before I come to the TME position, and I support ACI for quite a long time. And if this is related to a data plan problem, the first question I will always ask is, where's your endpoint? What is your IP address and MAC address, and where's your endpoint? In order to narrow down the problem, right? The faster you can narrow down the problem, the faster I can solve the problem for you. So that's all this question. Then that will lead another set of a question is, what information I shall collect in order to answer this? And how do I collect this information? There's several ways. You can do show command. You can get some information from show command. You can get some information from SMP. That's fine. And if I collect all this information, what I can do? What I can do with them? And this is the question that we want to solve today. And you probably think, okay, yeah, I'm collecting information. I'm using the show command. I'm using the API to collect information. Or I've been using my SMP for over 20 years. It's working perfectly. Why would I change to streaming telemetry? So that's coming to the next why. It's performance. So this is a quick comparison between you get interface information from the SMP, the interface MIP. Use BRKDCN. And this is how you streaming telemetry. Basically, you're streaming the DME. We are going to talk about what is DME later, but just a quick remind this, DME is our raw database. You're streaming our raw database about interface information. So quick comparison between these two, streaming all the interface. I don't have many interface out, to be honest. It's take about close to 3 seconds to get all the interface information from the interface MIP. And so streaming telemetry and using DME, it just take a little bit more 300 milliseconds. And that information is actually way more that you can get from SMP. This is all the information you can get from the interface. Configuration and the operational state and the transceiver state, everything you can get from this, just this pass. So this is a huge difference on the performance, right? So this is probably you need to think about maybe it's time to change from your old SMP-based monitoring system and to streaming telemetry. So we know why, and let's talk about how. First thing we need to think about is data source, because on NXOS, we have a different data source for streaming telemetry. And if each different data source has its advantage and also has its disadvantage. So you need to think about, based on your requirement. So first thing we're going to talk about is DME. DME is short for Data Management Engine. It is considered as a raw database of Cisco NXOS, okay? And it's a tree-like a structure, just like any modern software, and if there is going to design their database, it's always built like the tree structures because it's easy to source your data. So addressing in the streaming telemetry is really important because you need this address to find out what's the information you want. For example, when you want the BGP information, by the DME, because it's based on the tree, so you can just follow the path sys BGP instance. And this is all the information you can get from the BGP. Configuration, operational data. That's every single information you get from the switch. But, of course, even you can get everything and just follow a simple path, that's not what I suggest to you to do. You would want streaming specific information you want because in this path is a lot of information that you do not need. So we do have a filter. We do have a filter support in the DME. And when you're streaming telemetry, this is called distinguishing name. And this distinguishing name is going to be your sensor path. You're going to hear about sensor path quite a lot. So this is going to be your sensor path. And what you can get from DME? Like I said, DME is our raw database. That means you can get everything. Every single information you can get from the switch. Even you cannot get it from the CI, you can get it from DME. Okay, this is a raw database, but it's vendor specific, of course. It's only implemented on the NXOS. Yes, you do need a little bit learning curve about how do you filter properly for the data. Right? This is a DME. How do we get that? we have two ways. One is we have a database, right? Of course, we have to design some like browser for the database. That is called Visuary. This is built in on every single NXOS OS. And whenever you enable NXOS API, and you will have access to this URL and to navigate to find out what's the information available. So for DME, it's designed by the component. All the subcomponent is on the root. Root is the sys, right? And BGP is the subcomponent, ISS, OSPF interface. It's all subcomponent. And you can pretty much tell from the name, for example, this is the interface. And all the interface related information is under this. So navigate is one way. And another way is, well, DME is not originally built just for streaming telemetry. It's actually built for automation. So this is our DME data, and actually we can automate every configuration from DME. So that's why we have this reference guide. We have this API reference guide for the DME. And if you're already familiar with DME, then you can just go to the developer documentation and find what's the streaming telemetry, what's the sensor available for each object. And you can tell, okay, this object is for interface high capacity input statistics. You can find that information. So other than DME, this is vendor specific, of course. And of course, NXOS OS is always based on the open standard. We support all the open standard protocol and all the open standard encoding. So we support YANG. You must have heard about that because in the past few years, the YANG automation is quite popular. Everyone is talking about the NetConf and RESTConf and YANG model, OpenConfig, right? But we both know it actually didn't go well. The automation use OpenConfig didn't go well. I don't believe any customer is actually, any people here is actually using the OpenConfig to automate their network. Is there anyone? Anyone can raise their hand? Prove me I'm wrong. Okay, cool, I'm still right. So no one is using the automation YANG model, OpenConfig YANG model more specific for the automation, but it's actually pretty good for streaming telemetry. It does have the general information available for most of the customers using in their network. Interface, we have interface module, BGP module, routing protocol. We have all this information. And this is already enough for you to monitor your network. So we can use the YANG to streaming telemetry, right? YANG itself is just a data modeling language. You can use this language to describe anything. Some customer or some product might use a YANG model to describe their API interface. That also can be done. In NXOS OS, we support two different types of YANG model, like any other operating system, different vendor. We support OpenConfig YANG model. I would not say this is like open standard, but it is more like a mutual agreement from different vendor. A different vendor agree, okay, we're going to support this OpenConfig YANG model. That's just a mutual agreement from different vendor. And also, we support some vendor-specific model, which is in Cisco, we usually call it the native YANG model or DLS YANG. So this is a vendor-specific YANG model. So we have two different types of YANG model support here. So when you are using YANG model to streaming telemetry, you're going to working on something called XPath. This is a format that usually we address in the element in the XML documentation, but we borrowed that for the borrow that for the YANG model. So this is like the sensor path that you're going to use to stream in the telemetry. And you specify, okay, which model it is, and the model, which container, which leaf, and eventually, which leaf it is. So this is how you're addressing the metric you want to stream from the NXOS OS or from any device because it's OpenConfig. So in Cisco NXOS OS, you don't have to worry, like pay attention to this one, but I just want to list here. This is like the common model that we support on Cisco NXOS OS. And the other version, I would not say this is the latest one, but it is close to the new one. And each version of NXOS OS definitely is going to support a different reversion because we keep adding a new leaf and keep adding new support on each individual NXOS OS. But unfortunately, OpenConfig is not enabled on NXOS OS by default due to some history problem. And also, this is function is not shipped with NXOS OS image before 10.2.2. That means before 10.2.2, in order to support OpenConfig, you have to install an extra software, extra RPM packet on your NXOS. It's actually due to some historical reason I don't want to mention here, but we fixed that. After 10.2.2, you can just simply use a feature OpenConfig to enable that. Okay? A lot of people, the reason why they choose OpenConfig is because they think OpenConfig is vendor agnostic, especially for multi-vendor scenario. They think, okay, I can use the same set of the sensor paths to streaming anything from any vendor. But the reality is a little bit different. So you see, the vendor can claim, okay, we both support BGP, we both support RACP or RDP, but it doesn't mean that they support every single leaf or every single container in the model. That means they will create a deviation. So be aware of that. You definitely to be aware of that and to take a look at what is actually a deviation that the vendor created and to see if there's too much difference between the two different vendors. Okay, and how do you find that? How do you find which version we do support? So on NXOS, we publish the version of the OpenConfig models on the GitHub for each version. So you can always go to the GitHub to find out what is the version support, what is the model support on your running version. Okay, makes sense? The VXLAN EVPN model. So the problem of the OpenConfig model is it's a general information. It's way behind the industry, to be honest. So for example, it's an OpenConfig YARN model. We have been implementing the VXLAN EVPN in industry over 5 years, but we just released this one. And Cisco did co-auth with Google and Telefonica for the OpenConfig VXLAN EVPN model, and we're going to support on Cisco NXOS on the next release, 10.3.1. And this is the first component that we're going to focus on the first release. So I don't want to jinx that, but I hope Cisco is going to be the first vendor in the industry to support this model. I hope so. I don't want to jinx that. Okay, so OpenConfig, and we know there is some information might not be available because it's a little bit behind the implementation of the vendor. So what I can do, if I still want to use my YARN model, but I want to get more information, that is the second YARN model that we support, which is called native YARN. Remember I mentioned the YARN itself is a data modeling language. That means you can use a YARN model, you can use YARN to describe any type of tree-like structured data. So our DME is tree-like structured data, right? So that means we can technically use YARN to describe our database, describe our DME, and that's become native model. That means native model to DME is 1-to-1. Wherever you can get DME, you can get native model, you can get the YARN, and you can use the XPath to source the data. For example, this is the path for DME, for BGP information, and convert to YARN model, then this is your path. Cannot be equivalent, right? It's just that we add some item, and because this is a container list. And yeah, also same thing as OpenConfig. We publish this YARN model on the GitHub, and you can find whatever the information available in the native data source. Sorry, the native YARN model. Then come to the question, how do I get that? Yeah, I have a YARN file, and I don't know how to read that. It's just a plain text that describes a YARN. It's really hard to read, to be honest. If you're not a developer, it's kind of hard to read the YARN model. So that's why we know the pain point of the developer, of the network engineer, and that's why Cisco published a tool called YARN Suite. And I'm not sure I have ever used YARN Explorer, and which is already kind of retired. It's not maintained anymore, but this YARN Suite has been used inside Cisco for over years, and we decided to open source that. I suggest all my customers, all the customers I talk to, I suggest them to use this YARN Suite to work on any YARN-related automation, NICONF or the streaming telemetry, because it's really easy to find out what's the information available in the set of YARN, instead of the YARN model. So it has a built-in YARN Explorer, and it's GUI-based, and you can just click and find out what's the information. And moreover, it has a plugin built in. It has a netconf JMI plugin built in. You can just quickly test that with the Young suite. And you don't have to build anything else. You just need this tool to test your JMI and test your the streaming telemetry. Okay. So we know the data. Now we know, okay, what's this data source available and where I can get this data. But how do I subscribe that? Usually when we're streaming the data, we call that a subscription, right? We call it subscription. How do I subscribe? You probably heard about that. We have two ways. It's called a sample-based subscription and event-based subscription. Basically, from the name, you can tell the sample-based subscription is subscribed based on interval, and event-based is based on the event notification. So how does it look like? Let's take a look. The sample-based interval is relatively easy, and most of the sensor paths will support this. So at T0, when there's a subscription come in, and for example, in this example, I'm going to subscribe the operational status of all my interface on this switch. Okay? On T0, I get the full collection of all my interface status. And then let's just assume that we subscribe like 30-second interval. Okay? After 30 seconds at T1, we get exactly same collection. All the interface status is up. I'm happy, but is there any interface like a flapping in the middle? This is 30 seconds. It's quite a long time. It could happen, right? The flapping could happen. So is there any flapping in the middle? I don't know. I just get, okay, after 30 seconds, all my interface operation status is still up. And at T2, I get a collection, but shows my interface Ethernet 1/2 is down. Okay, I got that information. I got the information after 30 seconds, but when did that happen? I don't know. It probably happened anywhere between T1 and T2, right? This is a simple-based subscription. And every single time you get basically the same amount of data. Every collection you get the same amount of data. So what's this event-based? Event-based on first collection, and when you subscribe based on the event, it's the same. We take a snapshot of your operational state of your interface and streaming to your collector. And then it will keep silence. And it will not streaming anything until someone come in and shut down the interface or plug the interface and plug the transceiver. And Ethernet 1/5 is done. Then you will receive this notification immediately. As soon as it happens, you will receive the notification immediately. And the only information you receive is Ethernet 1/5 is done. So this is a big difference, right? Now, my suggestion to you is try to use event-based as much as possible, because you can see it can reduce a lot of the resource utilization, the CPU cycle on the NXOS, and also reduce the amount of data that's transmitted by the network. But it's not for everything. For the data that is continuously changing, for example, interface counter, it doesn't make sense to use event-based. And besides, to be honest, we don't support event-based on interface counter. So you have to use the sample-based, right? So this is the difference. Then coming to encoding. On Cisco NXOS, we support a major type of encoding. We support JSON, and everyone knows JSON and XML. So this is more about like a self-describing encoding method. So there's not much to talk about. I believe everyone knows what's this JSON and what's this XML. It's just a matter of the schema of the JSON. But we also support GPB because we support gRPC and we support a JMI del-in. So we do support GPB, which is Google Protocol Buff. So how does GPB work? So the original format of GPB is everything is binary. Everything is going to be encoded as binary. How does it do that? This is an example collected from the OpenConfig interface counter. Okay, so we have all the counter available for this interface. And we need a file called a proto file to encode that. Like I said, it's going to be encoded as binary. What's it going to look like? It's going to look like this. You see that all the key, which is like, for example, the ingress broadcast packet, is going to be encoded as 1, a digit 1. And the data, as of course, is going to be encoded as is going to be encoded as a binary for sure. So you can see that after compare the original data size and the final data size, the data size reduced dramatically with the proto, right? It's dramatically. It's probably like a 1/10, like a 1/10 of the original data, even more. It depends on how you encode that. But problem is, when the receiver receives that, how does the receiver know what does 1 mean? I don't know. I don't have no idea what does 1 mean. So that means we have to distribute this proto file between the encoder and the decoder. That means between your streamer, like the NXOS and your collector. So it's create a bigger problem for streaming telemetry because you see how many K we hear. Every single K we need to map to 1 digit. And think about it in the open config. We have over 100 model. And the problem is for open config, it's constantly changing. It's keep changing, to be honest. Open config model is keep changing. So this is a model, we have to create this proto file for each individual model in order to decode and in order to encode and decode correctly. Yes, it is high wire efficient, but it is really hard to develop the encoder and decoder part for the streaming telemetry. So what's the other option? So we developed something called JPB key value. The format is still still a JPB, still Google Protobuf, but in a nutshell, we encode the key as plain text and the value to the binary. So you can see that basically we separate the original key and the value to 2 sets of data and encoded the original key as plain text and original value will encode it based on the tab. So this is all egress octets. This is on-site int 64. So we encode as the key for this data is 8. So when the collector receives that, okay, we know what the type of data it is, or the data it is, then we can decode this binary value correctly. So this is how we do it. We choose to stand in the middle ground. And of course, you can see that the original data size and the encoded data size, not much difference. But the good part of that is this is all you need for no matter which model you are using, this is all you need in order to encode and decode data. So yes, less wire efficient, but it's easier for developer to develop the encode and decode part. So this is how the JPB key value work. Okay. Yeah, and this proto file is published on GitHub, of course, and we have that published, and it's not changing. By the way, this proto file has been there for quite a long time. It's not going to be changed between different versions. And then let's talk about the design consideration. When you heard about the streaming telemetry, you probably always heard about the 2 concepts, which is dial out and dial in. The big difference between the dial out and dial in is actually just who initiated the TCP connection. For dial out, TCP connection is initiated from the switch. And for dial in, TCP connection is established from the collector, but the switch is going to use the same TCP channel to stream information back. So it sounds really like simple. It's just who initiated the TCP connection. What could be the big difference? But actually it brings quite a lot different when you consider about design, especially for scale data center. There's quite a lot of difference. So quick comparison between dial out and dial in, right? And the protocol is a little bit different. For dial out, it doesn't matter. We support all kinds of encoding. We can even stream information just using route UDP packet. And for dial in, so far we only support the one protocol, which is gRPC, because it is actually GMI dial in. So GMI is built on top of gRPC. Okay, the protocol is a little bit different. And for dial out, collector doesn't know what is you are going to stream. So that means all the telemetry, the sensor path configuration is going to be configured on the switch. It's going to be configured on each individual switch. But that configuration tend to be static or tend to be same across your entire network. So you can automate that configuration quite easy, right? It's not a big problem. For dial in, that we are using a single channel for the subscription. Basically for dial in is the collector is going to tell the switch what information I need then switch is going to stream that information, use the same TCP channel. Okay, so that's why so the configuration of the switch is really simple. Just enable the service and give some certification. That's it. And because of TCP connection, that's actually make a difference. And because we're doing that out, it's egress from a switch perspective, right? And we are establishing egress direction, so you don't need to open any specific port on your management network. I know some customer does have really, really strict rule for the ingress direction. It will not open anything other than, well, they basically don't open anything, to be honest. But for dial-in, it's going to be really hard for this type of customer because you have to open a separate port in order to establish connection from external to your management network, right? It's a big difference here. And load balancing is going to create a little bit difference on the design consideration. So let's talk about that. This is dial out. For scale setup, well, for simple setup, you just need one collector. You don't have to care about like load balancing. Just one collector handle like a 2040 switch, fairly easy, no problem. But if you have a scale setup over 100 and even 1,000 switch, there's no way you can handle that with just one collector. So you have to build some load balancing. Because of the nature of TCP, if you're using dial out, relatively easy. You just insert load balancer in the middle and use the VIP for the telemetry collector. And then the load balancer is going to handle the load balancing for you. And fairly easy, right? But for, well, I will say straightforward. For dial-in, again, because of TCP, and it's against the nature of the load balancing, you cannot do that. You cannot just simply insert a load balancer in the middle. So in order to distribute the workload, basically you have to distribute your collector and let them to dial into a different group of the switch. And then you need to think about, okay, how do I keep redundancy? Basically, you have to keep like, how do I keep the redundancy? And then how do I synchronize the configuration, the sensor path configuration on each different collector? So it's doable, definitely. We do have some customers because they want to use dial-in and they have to design something like that. But it's not straightforward as dial-out, right? So there's some design consideration when you design the telemetry. And then we talk about like a dial-in, and like I mentioned that we only support one type of a dial-in, which is built on a GMI. And let's just quickly go through what is a GMI, in case you haven't heard about that. So GMI is short for gRPC Network Management Interface, right? And it's built based on the gRPC. Essentially, it's specify a set of RPC in order to manage your network device. Obviously, it's the network management interface. And it supports both configuration management and streaming telemetry. We're going to talk about what is a RPC that it supports. And it built based on the gRPC framework, so it can benefit something from gRPC, especially the HTTP2. Well, has some flow control on the HTTP2 that GMI can benefit from that. So not like a netconf, right? For netconf, netconf has some extension, but netconf essentially it is using YANG model. It's basically strictly using the YANG model and without any extension of the RPC. But the GMI doesn't, and it's designed to carry any tree structured data. Any tree structured data can be carried over by the GMI. That means we can use DME. We can use our DME in the GMI. And it just offers alternative to the netconf and RESTconf. Quite a lot of capabilities a little bit same as the netconf. So let's say what's the gRPC support. Capability, get, and set, pretty familiar, right? If you have ever used the netconf, it's pretty much the same as netconf. We have a capability and to say, okay, what's the model we support, and what's the encoding we support, and get and set is used to manipulate your configuration. But it has some unique RPC which is called subscribe. So subscribe is basically the message that tells the target what information I want, and you need to stream in the information based on the event or based on the sample. So this is a subscribe RPC. This is the one that we are using for GMI streaming telemetry, dial-in telemetry. We implement the GMI on NXOS since 921, sorry, actually 921, and this is based on the version 050, not latest one, but it has enough capability for streaming telemetry. So RPC capability, we support full set of the capability here, and for streaming telemetry, we support on-chain, which is the equivalent to event-based, and also we support a sample-based telemetry. And we also support something called target define. That means if you don't know you want to stream in based on sample or event, just let target to decide it for you. Target will choose based on the type of the sensor. So the target define, we support that. And also there's two sub-options for the streaming telemetry, which is suppress redundant and heartbeat interval. So suppress redundant is basically used for the streaming, for sample-based streaming telemetry. And if there's no change, then it's not going to stream the exactly same information to the collector. So it will reduce the redundant, the way to reduce the amount of data you're streaming from the telemetry. And the heartbeat interval is reverse, is for event-based. That we know that for event-based telemetry, if there's no change, it's just going to keep silent for all the time. Not going to tell anything. Sometimes you even think, okay, is this switch actually dead because I didn't receive anything? So the heartbeat interval is used to, okay, even there's no change, I still want to get the latest snapshot, for example, every hour, every 24 hours, right? So that's a heartbeat interval. And it's going to support, it's actually already supported in 10.2.3. And the security, really important. On the GMI spec, TRS is mandatory. And that means if there's if TRS is not used, the target should be just a closed TCP connection immediately. So we implement based on the GMI specification. TRS is mandatory, and you have to give a certificate in order to configure GMI. But if you don't give it, and we will give you a self-signed certificate, which is valid for 1 day. And we support mutual TRS. That means instead of using the username and password to authenticate on the GMI, you can use a certificate to authenticate with a switch, okay? And data modeling, like I mentioned, that we support OpenConfig, GMI, OpenConfig model, native model, and encoding we support GPB, key-value, and JSON. And we also have a wildcard support, which is kind of used to filter data, or not filter data, like to stream the data, which is also support on 10.2.3. So this is a general capability here. Then how do we build a streaming telemetry? Like I promise you, I definitely will give you something you can take it back, not just listen to this theory and the capability here. And you definitely want to see that in action, right? How do we build that? Luckily, we do have some open source out there, which is work quite well with the streaming telemetry. And this is your fabric, right? We have a fabric, and depends on what is the data source you are using. You can use a YAML model and DME. Usually for customer, they are going to use, sorry, you're going to pick one. They're going to pick one. No one is going to combine dial out and dial in. They're going to pick one between the dial out and dial in, then streaming that information to the collector. There's one really popular collector which is called Telegraph. Have everyone heard of that or used that? Perfect, perfect. Telegraph, we have two plugins. Telegraph is open source. It's the powerful of Telegraph is you can build any type of like ingress tab plugin on Telegraph to consume any type of data. So for Cisco, we built two plugins. One is the GMI. It's actually originally called Cisco GMI plugin. And also we have MDT, which is a modern-driven telemetry. Essentially, it's for dial-out telemetry. So we have two plugins built by Cisco, which is upstream to the Telegraph. You can use these two plugins, and depends on which transport option you want to use. So once the Telegraph gets the data, what's it going to do? It's going to convert the data. Well, data is coming in the GPB or JSON. We're not going to write the data directly into the database. It's going to be converted to the data that can be understood by the database. And streaming telemetry, we're using a specific type of the database, which is called time series database. Well, pretty popular tool is InfluxDB and the Prometheus. And you can write data to this type of write measurement to the time series database. This is how you store data, okay? You store data, but still you want to use that. And one of the most strict way is using a dashboard. You can build a dashboard to query the data from the time series database. And there's two popular ones. Well, technically, actually only one. So Grafana is a really popular one, and a lot of people is using the Grafana. Even inside Cisco, we are using the Grafana for some product. Before we have a chronograph, which is also developed by the NXOS Data, but I guess they are stopped developing that. And yeah, Grafana is a really powerful dashboard that you can query data from time series database and based on range. Sorry, question?
Just commenting that the NOC stuff that they were showing downstairs from Cisco was all done with Grafana.
Oh, that's cool. I did not know that. Yeah, it's really powerful. You can streaming. You can like visually analyze anything, and Grafana and like build a dashboard. And also, and on top of that, it's just a visualization, right? It's really good to see, but you want to use this data and set up some notification. For example, if a threshold of your interface utilization above a certain level, and you can send notification. In the InfluxDB, they have some product called capacitor. Yeah, I think so. It's you can send the notification. So how do we get started? I know, and most of us are network engineers. We're not that familiar with this software stack. So that's why I built this repo that it will leverage Docker and to build all the software stack, Telegraph, InfluxDB, and Grafana. And also it has some built-in configuration for streaming for the sensor paths, for GMI sensor paths, and also has two dashboards built in for the example. One dashboard is querying the data from the GMI dial in, and one dashboard is querying the data from the MDT dial out. You guys have ever used this before? No? Okay, it's fine. So this is the link, and it's definitely encoded in the slides, and you can just find this. Really simple. I get quite a lot of positive feedback from the customer, and they like it. So this one is this is exactly the dashboard you're going to see once you build with this tool. It's just one command, basically just one command. It will run all this software by itself. And it's a beautiful VXLAN EVPN fabric. You can see that it's just too blurry, but we are querying some layer 2 EVPN information, the EVPN information and the BGP information, and also the interface counters. But it does has a lot of like basic environmental and the routing, the protocol information there. So you can use that as jumpstart to deploy the telemetry system in your network. Okay. Quick summary, takeaway. We have a wide choice of the data model and the streaming transport options, and we are open source. And we're not open source. We are based on open standard. You can choose based on your actual business requirement. And we do have a lot of customer interest in GMI dial-in. The most important is because you can see the GMI dial-in can support the configuration management and the streaming telemetry. So they like the idea. Use one protocol for automation and for streaming telemetry. But you can see that it does need some design consideration when you deploy the GMI dial-in for the scale network, right? And to optimize resource utilization, only stream whatever you need. Don't start from the top level. That's a waste a lot of resource on the target, and also going to waste a lot of resource in your database. Streaming whatever information, only the information you need. And use GPP key value when possible. And the JSON is also supported if you really need the JSON. And GPP is definitely, the decoder part is actually more efficient than the JSON. And use the OpenConfig model first. And most of the information in the OpenConfig should be enough for the general use case. But if there is an information that you want which is not available in the OpenConfig, you can always fall back to a DME or the native data model. Okay? So that's today, concluded today's session. And last thing, really important, I really appreciate your feedback, and please submit a survey, and so I know that what I can improve, what you like, what you don't like. Thank you. Thank you very much. And this is the last session of the entire Cisco Live. Well, last set of session of the entire Cisco Live. I really appreciate your come here, and really appreciate come to Cisco Live and come to this session, and safe flight home. Thank you.